This is Unit 10, Example 7. So in Example 7 and 8, we'll be using the t-test. So hopefully you've read a bit about the t-distribution in your packet and on OLI. For our purposes, we'll treat it very similar to the normal distribution, and the shape is very similar. Students in an LMC statistics class conducted a research survey to find if people carried more than 50 cents in their pockets. The students surveyed 125 people in as close to a random sample as possible. The sample mean was 0.53 or 53 cents, and the sample standard deviation was 0.275. Test the student's claim and explain your conclusion. First, we state the claim. So the claim is that people carry more than 50 cents in their pockets or purses. This will correspond with the alternative hypothesis. The null hypothesis will assume the mean equals 50 cents. So when we write our hypothesis, for the null hypothesis, we say that the mean equals 0.50. Remember, we're trying to predict the true population mean. And the alternative hypothesis is that the mean is greater than 0.50. So step 3 is now to assess the evidence. If we're on the graphing calculator, you can go to Stat, Tests, and choose Test 2, the t-test. And we use the t-test because we've got sample data only. We don't have information about the population. If we go into StatCrunch, we'll go Stat, and then we choose t-stats. And we're working with one sample, and we know the mean and the standard deviation, so we choose with summary. So our sample mean was 0.53. The sample standard deviation was 0.275. And the sample size was 125 people surveyed. And we're comparing this to a population mean of 0.50, and our alternative hypothesis is that the true mean is greater than 50 cents, or 0.50. And if we compute, we see here the t-stat is 1.21 or 1.22 if we round it, and the p-value is 0.111. So if we go into Options, Edit, and check p-value plot, we can see also now, if we click to the right, here's the p-value plot, and we see more than 5% is shaded. The p-value was 0.1125, and the t-stat was between 1 and 2 standard deviations, so not what we think of as significantly outside the reasonable range. This corresponds with the values you get if you're using the TI calculator. So now step 4 is to state our conclusion. So the p-value is not less than 5%, 0.05. So we say there is not enough evidence to reject the null hypothesis. The sample does not support the claim that people carry more than 50 cents in their pockets. The null hypothesis could be true. So what we found is that the sample doesn't give us enough evidence. It could be possible to go out and collect more data and results change, so we can't say for certain that the null hypothesis is true. But for now, we don't have enough evidence to say that it's false, so we say it could be true. Example 8 is using the 2-sample t-test, and so this is medical data from medical Dr. James Levine and his collaborators, the Mayo Clinic, and they investigated the link between obesity and energy spent on daily activity to see if the non-obese subjects were more active. So in the table, we have the two groups, and you can see their small sample sizes. N is 9 in the first group and 11 people in the second group. And then we have their mean minutes of daily activity and the standard deviations. Step 1, we state the claim. So the claim is that non-obese patients are more active, or are active more minutes per day than the obese patients. So the claim corresponds with the alternative hypothesis. The null hypothesis assumes equality between the two groups of patients. So when we write our hypotheses, we're assuming that mu sub 0, or we could say mu sub 0, that's the population mean, is the average minutes per day having 0 difference or no change between the two groups. And then our x bar 1, there should be a bar on the x, is 525.751 minutes for the non-obese group, and X bar 2 is 373.269 minutes for the obese group. These are the data values from the study that are in the table. And then we've got our null hypothesis is saying the two groups are equal, mu1 equals mu2. And our alternative hypothesis is saying mu1 is greater than mu2 because the claim is that the first group is more active. If you're on the TI graphing calculator, you'll choose stat, test, test for, the two-sample t-test, and for pooled, you'll choose no. We'll go into StatCrunch in this video, and we'll see we get the same results. So in StatCrunch, you can exit out of the old results. We go to stat, t-stats, two-sample with summary because we're given the sample means and the sample standard deviations. So for sample mean 1, we put in the values for the first group. It does not matter if you reverse the groups, just know that you will get a negative standard deviation. We put the sample standard deviation for the first group, and the sample size for this first group was 9. Remember, we're doing a t-test because we don't know the population data. And the sample size for the second group is 11. So we're going to uncheck pooled. We don't want to pool. And then here, because we're testing no difference for the null hypothesis, we say the difference if you subtract them is 0. And then our alternative claim is that the first group is significantly greater than the second group, so we make our inequality greater than. And then for output, I like to choose the p-value plot also. And we compute. And in StatCrunch, we get a lot of other statistical information. Over here at the end of the table is the t-stat and p-value that we're after for analysis. The other information is telling us the sample difference, the standard error for the sample difference, and then an idea called degrees of freedom that we'll see a little bit in Unit 11. So here our t-stat is more than 2 standard deviations, 3.71 standard deviations, and our p-value is less than 0.05. So that's significantly different. And if we look at the distribution chart, we see even here in the t-distribution, it looks a lot like normal distribution. The 3.7 standard deviations is far out, and so it looks like it's unlikely that the null hypothesis is true. So now we want to state our conclusion. So the p-value is very small, so there is enough evidence to reject the null hypothesis. The sample does support the claim that non-obese subjects are more active.